Dear students, today we are going to discuss UG third year 5th semester mathematics paper, that is linear programming problem. Under this, now we are going to discuss solving the given linear programming problem by simplex method. Okay. In this LPP, this is one of the most important method, that is simplex method. Whenever the LPP is given, how we are going to solve the problem with the help of this simplex method. And after studying this simplex procedure or simplex method, the students are able to understand the need and importance and uses of simplex method, and the students are able to form the given LPP in the matrix form, and the students are able to write the algorithm of simplex method and the steps which are involved in LPP using simplex method. They are able to know all these points. Now coming to the introduction part. In the year of 1947, GB Dantage initiated an Air Force project named Scientific Computation of Optimum Programs, SCOOPs. This method makes use of an iterative procedure called simplex method. So this method, actually this operation research OR paper was introduced at the time of Second World War. Before that Second World War, actually there is no the subject operation research. At the time of Second World War, this subject was developed and introduced. Okay. This simplex method provides a systematic approach to find an optimal solution for the given linear programming problem. In this method, we start with a basic feasible solution and move to another solution, that is from the basic feasible solution to original solution. Each time as we move from one vertex to other objective function to improve towards the equality or optimality. Next, when here this simplex method is applicable whenever the number of decision variables are 2 or more. Okay. If it is more than 2 variables are there, definitely we have to solve the LPP with the help of this simplex method only. Okay. And whereas graphical method, when exactly 2 variables are there, then we are using graphical method. But more than 2 variables are given, the graphical method is unable to find the solution. In that situation, with the help of this simplex method, we can obtain an optimum solution. Before going to start the simplex method, let me discuss few definitions. First, coming to the slack variable. Slack variable means a variable which is to be added for less than or equal to constraints to convert inequation into equation. It means, let us suppose Axi less than or equal to Bi is there. Let us suppose I am giving the one equation, Axi less than or equal to Bi. For converting these inequation into equation, I am going to add certain addition variable or certain quantity on left hand side only for making this inequation into equation. So whatever the additional variable we are going to add, that variable is called slack variable. So the definition is the variable which is to be added for less than or equal to type constraints to convert inequation into equation. That additionally we are going to add, that variable is called slack variable. Similarly, a slack variable represents unused resources, and a slack variable contributes nothing to the objective function value. Similarly, come to the next one more definition, surplus variable. Come to the definition of this. A variable subtracted from a greater than or equal to constraints to convert inequation into equation. That kind of variable, whatever the variable we are going to subtract from the left hand side of the inequation to convert inequation into equation, that subtracting variable is called surplus variable. For example, here xn greater than or equal to bi. Let us suppose xn greater than or equal to bn. So, for converting these inequation into equation, I am subtracting certain quantity from left hand side only. Xn minus, let us suppose xn minus s1 equal to b1. So, here we are subtracting s1. This s1 is called surplus variable. So, a surplus variable represents an excess above constraints requirement level, and a surplus variable contribute nothing to the calculated value of the objective function. Next, few more definitions. Basic solution. The solution is obtained by setting any variables equal to 0 and solving for remaining variables, provided the determinant of the quotient of these variables is non-zero. Such m variables are called basic variables and remaining n non-zero variables are called non-basic variables. And a basic variable solution. So, the meaning of this word basic variable solution is, it is a solution which is also satisfies the given non-negative restrictions. And a basic variable solutions are two types. One is degenerate basic variable solution, another one in non-degenerate basic variable solution. Coming to the what is the meaning of degenerate basic variable solution? If one or more basic variables are 0, yes, if one or more basic variables are zeros, then that kind of solution is known as degenerate basic variable solution. And next, coming to the non-degenerate basic solution, all basic variables are non-zero. In that given problem, all basic variables are non-zero, then that kind of solution is known as non-degenerate basic variable solution. And coming to the optimal basic variable solution, the optimal basic variable solution means the function, the objective function which is going to be either minimized or maximized is known as optimal basic variable solution. Coming to the how we are going to represent the given linear programming problem into matrix form. So, first, what is the standard form of LPP? Sorry, the general form of LPP is, as there will be one objective function z equal to either maximum z or minimum z. Z equal to c1 x1 plus c2 x2 plus c3 x3 plus data up to cn xn. In this, I am going to take n decision variables or n unknown variables. So, maximum or minimum z equal to c1 x1 plus c2 x2 plus data up to cn xn. And coming to the subject to the constraints. Subject to the constraints are in the form of a11 x1 plus a12 x2 plus a13 x3 plus data dash up to a1n xn, either less than or equal to or greater than or equal to or equal to b1. Similarly, second constraint a21 x1 a22 x2 a23 x3 plus data up to a2n xn, again which is less than or equal to or greater than or equal to or equal to b1. So, the constraints must be any one of these three formats, either it may be less than or equal to or greater than or equal to or equal to. Like that, I am taking m constraints. So, first, second, third up to mth constraint will be am1 x1 plus am2 x2 plus data up to amn xn, again it must be less than or equal to or greater than or equal to bm. So, this is the matrix form. Now, coming to the these are the linear equations with n unknown variables and m constraints, and write it into matrix form. Now, we have to represent these above LPP into matrix form. So, in this, the objective function is either it should be minimum z or maximum z. So, minimum or maximum z equal to c1 x1 plus c2 x2 plus data up to cn xn. This is known as objective function. And coming to the constraints, subject to the constraints. So, here I have taken m constraints with n unknown variables. So, write it into matrix form by taking ax equal to b, where b greater than or equal to 0, and this is known as subject to the constraint. And last, non-negativity condition. Whatever the decision variables we have, 1, 2, x1, x2, x3 up to xn, all these n unknown variables must be strictly greater than or equal to 0. These 3 steps known as LPP general format. And where in this X is column matrix with all unknown variables, x1, x2, x3 up to xn, and C is matrix with all the cost of the objective function variables, the cost of the, in the objective function, the cost of the all individual variables. C1 cost is, x1 cost is C1, x2 cost is C2 in that objective function. Similarly, up to xn cost is Cn. So, and I am writing all that cost into matrix form, that is C equal to C1, C2 right up to Cn. And where here I am adding 0, 0, 0 means these are the slack and surplus variables cost to put the objective function in the objective function. So, 0 into S1, 0 into S2 like that. Okay. So, C1, C2, C3 up to Cn and 0, 0, 0. And B is the right hand side values with B1, B2, B3 up to Bn. It is also column matrix, B1, B2, B3 up to m constants I have taken. So, B1, B2, B3 up to Bm, this is column matrix. And A is coefficient matrix. So, here how many constants we have? 1, 2, 3, 4 up to m constants are there. So, we have to prepare the coefficient matrix for all these m constraints. That is, matrix A will become first row A11, A12, A13 that is up to A1n. Second constant A21, A22 that is up to A2n. Like that up to nth constant will become AM1, AM2 that is up to AMn. M constants, n unknown variables. So, and at the last again I am taking the 100 up to 010, 001 like that is up to 001. These are the costs of the introducing variables, either slack or surplus variables. Okay. So, the vector C denotes here the cost vertex and which gives the corresponding coefficients of the objective function. The coefficients of the slack variables strictly we have to put zeros in the objective function, whether it may be slack variables or surplus variables, we have to put that cost of slack or surplus variables are strictly zeros in the objective function. That is why we got the matrix 1 0 0 0 up to m 0 1 0 0 0 like that, last row 0 0 0 up to 1. And the X is the column matrix which indicates all decision variables. Next, coming to the procedure for simplex method. So, before going to start the problems, let me discuss the calculation procedure or the algorithm of simplex method. So, in this simplex method totally we are using 8 steps. Step by step I will explain the one by one. First, in step 1 we have to check out the given objective function. First we have to check out whether the given problem is in LPP format or not. If it is LPP means there will be 3 steps. Objective function will be there, constants will be there and non-negative will be there. So, first we have to convert first that LPP problem into standard form. Then afterwards go for the simplex method. First here step 1. So, the algorithm of simplex method step 1. First we have to check out what is the nature of objective function. If the objective function is maximum, then go for the directly step 2. If it is the objective function is minimum, let us suppose the given objective function is minimum. So, first we have to convert it into maximization function by multiplying with -1, that is maximum z equal to minus of minimum z. Then go for the next step 2. In step 2, see here in step 2 first we have to convert all inequations into equations by introducing slack or surplus variables. As we have to see how many constants are there. In that constants, if there are inequalities are given, first we have to reduce or convert these inequalities into equalities by introducing either slack or surplus variables. Next, after introducing the slack and surplus variables and after converting the inequations into equations, write it into matrix form and write in a first equation S1 variable, second equation S2 variable, slack or surplus variable, and after introducing all slack and surplus variables, write in each and every individual equation, each and every individual slack and surplus variables, original variables will be present in proper order. First x1, next x2, next x3, like that. Next slack variable s1, s2, next surplus s2, s3, like that. So we have to write all into in proper order form. If any one of the variable is missing, we have to write 0 into that corresponding variable. Suppose in first equation, let us suppose x1 plus x2 less than or equal to 1, let us suppose. So it is less than or equal to in equation is there. So introduce slack variable s1. So x1 plus x2 plus s1 equal to 0, s1 equal to 1. Similarly, if it is second in equation, x2 plus x1 plus 2x2 less than or equal to some 5. In the second equation, again I am going to introduce s2 slack variable. So in first equation, s2 is missing. So write x1 plus x2 plus s1 into 0 into s2. Similarly, in second equation, s1 is missing. So write x1 variable cost with x2 variable cost plus 0 into s1. Next afterwards, s2 equal to right answer, whatever it may be. So like that we have to write all that into proper order. Then from that we have to pick up a sub-square identity matrix so that we can obtain the initial basic feasible solution, that is IBFS. After getting the initial basic feasible solution, coming to the simplex table. The first iteration of the simplex table will be like this. So this is the structure of simplex table. So first, the first row indicates Cj. Cj means the cost of the variables in the given objective function, including original variables, slack variables, and introducing slack and surplus variables. And next BV. BV means basic variables. So in that, write all variables in proper order, x1, x2, x3, right up to s1, s2, like that. Okay. And in that next matrix, it indicates all coefficient matrix must be written in that next column, next row of the matrix. And delta j. Delta j indicates it is the Zj minus Cj. The formula for calculating the delta j is Zj minus Cj. And this is the complete structure of simplex table. And next, we have to calculate one by one values. Coming to the next step, that is step 4. Now step 4. So after writing all values into the simplex table, now coming to the calculation procedure. Testing for the optimality solution depending on the values obtained by delta j, that is Zj minus Cj. See here, we have to move the next iteration. We have to check out delta j values, that is Zj minus Cj. If in the first iteration of the simplex table, if all Zj minus Cj must be greater than or equal to 0, it means there is no negative quantities, whether it may be zeros or positives, that is all delta j, that is Zj minus Cj values are greater than or equal to 0, then stop there only. It indicates the optimal solution is obtained for the given LPP by simplex method. Okay. If any one of the Zj minus Cj must be less than or equal to 0, means at least one of the delta j, that is Zj minus Cj, is less than 0, then go for the next calculation procedure. That is, among that all negative quantities, we have to pick up the most negative quantity. Okay. Among that all negative quantities, if more than one negative quantity is there, suppose minus 10, minus 5 is there. So minus 10, minus 5, most negative is minus 10. So we have to pick up that minus 10 and see that corresponding column vector. That indicates the entering vector of the simplex table next iteration. And once the one of the variable is entered, then I want to find the living vector also. For obtaining the living vector, I am using the last column of the simplex table, that is minimum ratios. So the formula for minimum ratios is xb by xj. Xb means the basic variables xb by corresponding entering vector, where we have entering vector, that column we have to take the denominator part, xb by xj, and these xj column values must be strictly greater than 0. If xj values are, one of the xj value is positive, then we can move the next procedure. But all xj values are either zeros or negatives, then it is an indication of unbounded solution. So while going to calculate these minimum ratios values, see what is the nature of xj values. If all xj values is either zeros or negatives, then it is an indication of unbounded solution. But if at least one of the xj value is greater than 0, then we can pick up the minimum ratios by taking xb by xj. So if 2, 3, 5 is there, let us suppose minimum ratios are 2, 3, 5. Among these 2, 3, 5, which is the least quantity? 2 is the least. So that corresponding row vector is the living vector. Okay, that corresponding vector will goes to living vector. And after getting the entering vector, leaving vector, and see where this entering vector, leaving vector going to intersect. That intersect part is nothing but key element, లేదా pivotal element, okay, or it is known as pivotal element. And next step, after obtaining the pivotal element, see what is the nature of pivotal element. If the key element or pivotal element is exactly 1, then go for the next step. That is, with the help of these 1, we have to make them its corresponding column elements are zeros by using elementary row operations only. As I will repeat once again here, if check out what is the nature of key element. If the key element is exactly 1, then we have to move the next step directly. With the help of these key element value, we have to reduce its corresponding key column elements into zeros by applying elementary row operations only. If key element is not a unity, by taking certain row operations, we have to make them into unity. Then afterwards, we have to apply the row operations and make them its corresponding key column elements into zeros. Then again, we have to check out the delta j values, zj minus cj values, and see what is the nature of delta j minus cj values. If all delta j minus cj values are greater than or equal to 0, then stop there only. That is the basic variables column values indicates that is the perfect solution. If at least one of the delta j minus cj is less than 0, again we have to pick up the most negative, that is entering vector, and go for the minimum ratios. With the help of minimum ratios, we have to obtain the leaving vector. So we have to repeat all these steps till all zj minus cj must be greater than or equal to 0. Once delta j, that is zj minus cj greater than or equal to 0, then it is an indication of the solution is obtained for the given problem with the help of this simplex method. Okay, let me discuss all these 8 steps with the help of one example. So here this is a simplex method flowchart. This is simplex method flowcharts. Here I will explain the this procedure once again. So here first express the given LPP into the standard form of that is maximization. Then compute initial basic feasible solution. Then come down, that is compute the net evaluation delta j values and see what is the nature of delta j. If all delta j minus zj minus cj values are positives, then stop there only, that is the solution. If one of the value is negative, that is delta j, that is zj minus cj values are negatives, then select the most negative from that all negative quantities, that indicates entering vector, and verify whether all constraints of the entries variables are negative or not, and select the positive coefficient and derive the corresponding values of the basic variables and choose minimum of such ratios that basic variable is the outgoing vector or leaving vector from the basis. Then again compute this entire procedure in a new simplex table with matrix operations, that is elementary row operations, and observe the nature of zj minus cj values. If all zj minus cj greater than or equal to 0, then we can reach, or it is an indication of we obtained an optimal solution. Okay, this is the flowchart of simplex method. Now instead of all that 8 points, just I will explain that entire procedure in brief manner. See here, the working rule or the procedure or simple algorithm of simplex method is formulate the LPP into standard form. Standard form means, what is the meaning of standard form? The objective function is always maximum z, constraints are always equality type, and non-negative conditions must be exist. And second step, set up the initial simplex table with slack or surplus variables. Next, third step, identify the decision variables which are to be brought in the solution, and examine the variables that are to be replaced, whether it may be incoming or outgoing, and calculate new values of the simplex table for entering variables. Do this same procedure till all zj minus cj must be greater than or equal to 0, and finally check out optimality conditions and write the solution part. Let us take one example. Okay, so what is the question? Solve the following linear programming problem by simplex method, and objective function is maximum z equal to 10x1 plus 20x2, and subject to the constraints are 3x1 plus 2x2 less than or equal to 1200, and the second constraint 2x1 plus 6x2 less than or equal to 1500, and the third constraint x1 less than or equal to 350 and x2 less than or equal to 200, and non-negativity condition is x1 greater than or equal to 0 and x2 also greater than or equal to 0. So this is the problem. In this he is asking solve this problem by using general simplex method. So first we have to check out what is the nature of objective function. Here the objective function is maximization. Okay, yes, it is in standard form. If it is minimization, first we are going to convert it into maximum, but that step is not required here. Why? Because it is in maximization only. So maximum z equal to 10x1 plus 20x2, and convert all inequations into equations. Here first constraint is 3x1 plus 2x2 less than or equal to 12. So I am adding s1. So 3x1 plus 2x2 plus x1 equal to 1200. Similarly, second constraint, third and fourth constraints. So I am adding s1, s2, s3, s4 for each and every individual constraints to make inequation into equation. So here s1, s2, s3, s4 are slack variables because they are less than or equal type. For that only I added s1, s2, s3, s4, and write all into in proper order. Objective function is maximum, that is before introducing slack variables we have only two variables x1, x2, but after introducing slack variables totally it will become 2 plus 4, 6 variables x1, x2 and s1, s2, s3, s4. Write it into an objective function. So that is 10x1 plus 20x2 plus 0 into s1 plus 0 into s2 plus 0 into s3 plus 0 into s4, like that. Okay. So each and every variable will be present in the objective function. Similarly, in constraints also we have to check out each and every individual variables. Original variables as well as slack variables must be present in proper order. That is here first constraint 3x1 plus 2x2 plus s1 equal to 1200. So here s1 is only present, s2, s3, s4 are missing. So I am writing that is 3x1 plus 2x2 plus s1 plus 0 into s2 plus 0 into s3 plus 0 into s4 equal to 1200. Similarly, second constraint 2x1 plus 6x2 plus s2 equal to 1500. So here s1 missing, s3 missing, s4 missing. So write s1 into in between x2 and s2. Okay, first s1 is comes, then afterwards s2. So it can be written as 2x1 plus 6x2. So here s1 missing, 0 into s1 plus s2, next 0 into s3 plus 0 into s4 equal to 350. Similarly, x1 plus s1 equal to 350. So here s1, s2 missing. So write it into proper order. x1 plus 0 into x2 also missing here. x1 plus 0 into x2 plus 0 into s1 plus 0 into s2 plus s3 plus 0 into s4 equal to 350. Similarly, in last constraint x2 plus s4 equal to 200 is there. So here the original variable x1 missing and 3 slack variables s1, s2, s3 are missing. Write it into in proper order. So 0 into x1 plus x2 plus 0 into s1 plus 0 into s2 plus 0 into s3 plus s4 equal to 200. Okay, this is the form, and from this we have to write into matrix form. X equal to column matrix with all unknown variables. B is right hand side variables 1200, 1500, 350 and 200, and A is the coefficient matrix. Okay, and C is the cost matrix, that is 20, 0, 0, 0, and write it into simplex table. This is the structure. In the algorithm itself I explained this all procedure. So Cj cost variables and basic variables, all variables, and whatever the initial basic feasible solution we got. Here the initial basic feasible solution is we have to pick up the 3 by 3 identity matrix 1 0 0 0 1 0 0 0 1. Okay, therefore s1 equal to 1200, s2 equal to 1500, s3 equal to 350, and s4 equal to 200. With the help of this we have to check out, we have to calculate the all zj minus cj values. So here zj minus cj values are minus 10, minus 20, like that. Okay, 0 0 0. So minus 10, minus 20, among this which is the most negative? Minus 20 is the most negative. So that is the entering vector, and see its corresponding we have to calculate the leaving vector. For leaving vector, coming to the minimum ratio formulas. What is the minimum ratio formula? xb by xj. So xb by xj means after calculating this I got 600, 200, and do not take zeros or negatives because xb by xj means xj strictly greater than 0. So it cannot be negative or it cannot be 0, strictly greater than 0. So the entering vector is column is 2601. So leave that 0 quantity. So 1200 by 2 means 600, 1500 by 6 means 250 and 355 0 means neglect that one because zeros are not taken, and 200 by 1, so 200. So we among this, which is the least quantity? 200 is the least quantity. So that is the corresponding living vector. So in this, S4 is living vector and X2 is entering vector. So with the help of this is the complete calculation procedure, and prepare one more table with the help of that corresponding entering and living vector. And in previous year, in this, where these are two quantities are intersecting, living vector and entering vector at S1, that is 1. So that 1 is the key element or pivotal element. So with the help of these key element, we have to make them remain its corresponding key column elements into zeros. Here key element is unity. So directly we have to apply the row operation so that we can bring it into in this format. Okay. Similarly, repeat this procedure till all Zj minus Cj values must be greater than or equal to 0. In second iteration, again we are getting one more Zj minus Cj is minus 10. Remaining all are 0, 0, 20. So only one negative. So that is the entering vector. And again coming to the minimum ratios xb by xj, 150 is the least quantity. So that is the living vector. So it's the intersection part is 2. 2 is the key element. Okay. In this key element is not a unity. First we have to make them into unity by multiplying that entire row with 1 by 2, so that it can be shifted to 1, and with the help of this one we have to convert all into zeros, and finally we got this is the matrix. So in this final matrix, Zj minus Cj's are greater than or equal to 0. So the optimum solution is obtained. X1 equal to 300, X2 equal to 150, and its maximum profit value is 6000. Okay.